Hey everybody, welcome back. So in the first part, we learned about conductors and insulators, as well as how to control the flow of electricity using resistors, or basically objects made out of semi-insulating material. So back to our original question, how do resistors affect the voltage and current in our circuit? Well, that's where Mr. Ohm comes in handy. So a few hundred years ago, Ohm figured out that resistors have a linear relationship with voltage and current, which looks like this. So basically, if you increase the current, either the voltage or the current must decrease. And if you plot the current versus voltage, current on the y-axis, voltage on the x-axis, also known as an IV curve, for a resistor, it looks like this. So just a straight line, no big deal. A larger resistance will have a smaller slope like this, and a smaller resistance will have a larger slope like this. Okay, so basically this just tells us that voltage across the resistor changes, and if we know the voltage across the resistor, then we can figure out what the current through the resistor is. So sweet, no problem. But what if we want to get a specific current because, for example, we don't want to burn out an LED or whatever sensitive electronic component that we're using? Then we'll need to pick a very specific value of a resistor. So how do we do that? Well, that's when it helps to know a little bit more about how resistors work. So the resistance of a particular resistor is given by the following equation, where ρ equals the resistivity, L is the length of the resistor, and A is the cross-sectional area. Okay, so how does this help us? Well, say we don't have a coin cell battery at home, but we do have a 9-volt that we definitely did not take out of the smoke detector. So powering an LED with a 9-volt absolutely needs a resistor because we'll totally burn out our LED, or we'll just like blow up our battery and then no more fun, glow time's lame. So let's build our own resistor and test it with the 9-volt battery and the LED. Yay! But wait, okay, so let's not get too hasty here and burn out our LED or ruin our battery. So what the heck is resistivity? Well, basically, that quantity just tells us how good of a conductor a material is. So here are the resistivities of silver and copper, which are conductors, and carbon, which is an insulator. You can also check out Wikipedia for a full table of all kinds of different materials. And so here are a few random materials that I gathered from around the house, some slidey pens. So which of these materials can we use to build our own resistor at home or in our classroom, lab, workshop, etc.? Oh my god, stay tuned for the next episode where we will learn how to build our own resistor and we'll go through why that works. Leave your answers in the comments below if you have an idea, and thank you for watching. See you next time.